Morning. It is Kimberly Pierce Dobson here, Business Development Manager from TBC-BRINADD. I'm here with Mark Leister, VP of Technology in not so sunny Houston, Texas. We're excited to bring you TBC-BRINADD's first ever webinar series over our technology. This is the second session of 7, and we will be covering our friction reducers today, our liquid concentrated suspensions. Every Thursday, we'll be broadcasting at 10 a.m. live, and we're so excited to share our product knowledge. Today, throughout the presentation, feel free to comment or question in the comment sections down below. We will have a Q&A at the end of the presentation. If we do not respond to your question, we'll also respond in an email. Feel free to extend the invite to your colleagues, as well as you will receive a recording post-webinar via email. You can always check our website at tbc-brinad.com and on our events tab to see our extended webinar series for the rest of the next 2 months. Again, as I was saying, every Thursday, 10 a.m., we will be broadcasting live to cover a new product technology. So without further ado, I'm going to announce Mark Leister, VP of Technology. He's going to be our speaker today for our Ultra DR system suspensions. All right, Mark, floor is yours.
Thank you, Kimberly. As a quick introduction, I wanted to mention that TBC-BRINADD is an accomplished global provider of solutions for non-damaging drilling, completion, workover, and fracturing fluids. Our goal is to deliver quality products and manufacturing services at a competitive price. We have been doing this for over 50 years. We have managed a quality management system since 2000 and attained the standards for ISO 9001:2015. This system requires processes in place to assess external and internal risks annually. So today's topic encompasses slick water suspensions trademarked as our Ultra DR series. These are formulated for performance in freshwater and elevated TDS field brines. So why slick water? Well, they're less costly, simpler, and effective. Wells completed with low viscosity slick water have yielded superior results versus offsets treated with other fluids in some areas. Preferably, selected slick water is homogeneous, readily pumpable, it yields nearly immediately, it's compatible with available field brine, and it sustains drag reduction during the completion. As a low viscosity fluid, velocity is a key factor to mitigate sand deposition, where reduction of pump rates for unanticipated reason results in loss of velocity. However, sustained drag reduction is dependent upon optimum hydraulics to achieve that critical velocity. So our Ultra DR suspensions are concentrated up to 48% by weight, and they range from 2 to 4 pounds per gallon. This reduces the product footprint and trucking. It subsequently reduces product usage, cost, and HSE exposure. In addition, TBC-BRINADD can customize formulations for specific field requirements. For example, suspensions greater than 4 pounds per gallon. These polyacrylamides are also available as dry. Our Ultra DR suspensions are stable for months. They're environmentally acceptable and non-hazardous. In a few slides, I'll show several QC/QA processes we use to ensure their stability, lack of separation, even settling. This ensures these suspensions are pumpable with existing additive pumps where no additional or special pumps are required, even in cold weather operations. The copolymers incorporated are all ground by TBC-BRINADD. This ensures every suspension and subsequent lot is manufactured to stringent specs to achieve optimum particle size. This in turn enhances rapid hydration and sustains drag reduction. Our grinding process produces a PSD that negates separation, mitigates settling of solids during transport, as well as long-term storage. As an example, this graph shows drag reduction for 3 different grinds of the same polyacrylamide. These flow loop tests were performed using a 10,000 TDS brine at 1 pound per thousand loading. The first 3 minutes are shown to exhibit the differences. The green line represents an unground PAM as received. The blue line represents PAM ground to a specific spec. The red line represents PAM ground to TBC-BRINADD spec, which is then incorporated into one of our UltraDR series. So an overlying characteristic here is that optimum grinding produces a polyacrylamide that is optimized. It achieves rapid hydration rate. This is characterized by assessing time to achieve 98% of maximum drag reduction. This is a value that we at TBC use to assess all of our suspensions. So note the vertical red line. This exhibits near maximum drag reduction in 2 seconds. The 98% of max is the difference in time from time start 0 to where the drag reduction value is 98% of the max. For this test, the 81.9 represents the max. Polyacrylamide grinds that are not properly ground will deviate relatively quickly from time 0, thus require additional time to achieve maximum drag reduction. This is exhibited by the blue and green lines. Also note that the 98% of max for these grind varies from 2 seconds to 55 seconds to over 5 minutes. The latter is an example of extended hydration time and impacts hydraulic efficiency, as the product or suspension, when pumped, has not fully yielded and does not reduce hydraulics. The time exhibited by the green line of product C may indicate not even full hydration upon entering the annulus. Also, optimum particle size aids in increased surface area. So all our UltraDR suspensions employ anionic polyacrylamide. They range from 2 to 4 pound per gallon active, and that our recommended typical usage ranges from 0.15 to 2.5 gallons per thousand to achieve the maximum drag reduction, as I showed previously. This table shows viscosity measurements of UltraDR1 M4 suspension. We use this data to assess the apparent viscosity. This is defined by the 511 reciprocal. The pump efficiency during the job. This is defined by the 100-second reciprocal. And then the pumpability. Our target is less than 3,500 centipoise at 25 C, and this is defined by the 4.2 reciprocal second. Measurement at each of these shear rates is terminated when torque of 100% is achieved. So using the data in this table, this suspension is deemed field ready and approved for use in an environment as low as 0 degrees centigrade. The UltraDR suspensions are formulated to perform in field brines ranging from freshwater to as high as 250,000 TDS. In addition, they are blended to perform in the presence of multivalent cations up to 20,000 TDS. While the TDS for DR1 and DR2 are nearly equal, the difference is the multivalent cations that they will perform in. So in the next few slides, I'll show flow loop results for the UltraDR suspensions using parameters shown in these tables. The top table shows synthetic brines that we formulated for use with the UltraDR series. With the exception of the nearly fresh brine, that's number 1, all encompass cations of calcium, magnesium, iron, strontium, barium, and boron. The anions comprise nitrate and sulfate. The hardness for these brines varies from less than 10,000 to approximately 40,000. The bottom table shows our flow loop properties. We use a 12-foot straight pipe with 4-foot entrance-exit curved half-inch tubing. At 14.2 gallons per minute, this loop generates Reynolds numbers ranging from 100,000 to 150,000. The latter equates to approximately 4.5-inch by 7-inch pipe and casing. Our average shear rate approximates 8,500 reciprocal seconds for a 50 to 86,000 K brine. Suspensions as well as dry are dispersed in 250 mils of brines shown above, and sheared at 1,000 RPM for 75 seconds before we introduce them into the reservoir, where they are immediately circulated. So let's look at a few examples. In this example, the Ultra DR1 M4, which is a 4 pound per gallon suspension, was formulated for use in up to 100,000 K brines. So I'm showing a 10,000 K brine on the left, 86,000 K brine on the right. The suspension was dosed at 0.2 and 0.25 gallon per thousand and 0.3 and 0.4 gallon per thousand respectively. For both brines, the drag reduction is sustained for greater than 70% for 10 minutes. These suspensions achieve nearly full hydration in less than 2 seconds, and this is exhibited by their 98% maximum DR value. Next, we use an Ultra DR2 M4 suspension. This is also a 4 pound per gallon concentration. This is formulated for use up to 100,000 K brines, however, for use with elevated multivalent cations. This brine was dosed at 0.4 and 0.5 gallons per thousand. In this brine, drag reduction is sustained for greater than 70% for 7 minutes. Again, nearly full hydration is evident by the vertical line in less than 2 seconds, and it's also shown in the table. And last, the Ultra DR3 M4, also a 4 pound per gallon suspension. This is for use in field brine up to 200,000 K TDS with elevated multivalent cations. This brine was dosed at 0.6 and 0.8 gallons per thousand. In this brine, drag reduction is sustained for greater than 70% for 8 minutes. But again, as the vertical line exhibits, full hydration in less than 2 seconds. As an example, viscosity measurements are shown in the two graphs for the Ultra DR1 M4. We use 10,000 and 50,000 K brines. At 4 gallons per thousand, the 511 averages 25 centipoise in 10K and 5 to 10 centipoise in 50K. The 40-second reciprocal ranges from 35 to 45 centipoise in 10K and 15 to 18 centipoise in the 50K as expected. At lower concentration, 1 and 2 gallons per thousand, the 511 averages 4 to 5 centipoise and 13 to 16 centipoise respectively as expected. And last, this chart shows viscosity results for the Ultra DR3 M4 in 100,000 and 200,000 K brines. The 511 averages 6 to 8 centipoise for both environments, and the 40 reciprocal second ranges from 8 to 13 centipoise for both as expected. We at TBC routinely perform quality control tests to assess pumpability and stability of our suspensions. We have applied these processes for over 30 years, and they have resulted in nil field issues. These processes mitigate separation, settling, and even gelation under storage, transportation, and field environments. As an example, I'll demonstrate 3 quality control tests. The first is our static aging. For this test, I'm showing an example of the Ultra DR2. This is approximately 47.2 weight percent suspension. Note the jars in the image, they were pulled after 60 days at 120 degrees. For the jar on the left, there's little syneresis, 1 or 2% by volume, and no separation. Turning the jar over immediately reveals that there's no gelation or solids that have accumulated. This suspension readily flows from the jar, indicating the suspension will readily flow from a bulk storage container. The next 2 tests are our freeze thaw and our bulk transport. For freeze thaw, we measure viscosity at 3 shear rates. This is shown in the table. The apparent viscosity exhibits less than a 12% difference from initial, indicating a stable suspension. The temperatures shown for the 3 cycles are where the suspensions freeze. However, all the properties are recorded at 24 degrees centigrade. But note the final measurement shows the suspension has maintained near original properties. The lower image is our bulk transport test. This test was developed by TBC-BRINADD to ensure our suspensions will readily pour from a container with nil residuals upon delivery to the well site, even after storage on location and subsequent use. We simulate transportation for 24 hours using an exclusive container. The container should empty rapidly without accumulation of solids after the 24-hour period. In this image, you'll see that there's no solids at the bottom of the container after the 24 hours. And finally, the Ultra DR2 suspension, the one that I mentioned before, this is an example where it was quality controlled after initial production run and then 30 days later from the same tote. The graph contrast drag reduction is measured from these two samples, again from the same lot. The drag reduction is identical and is sustained 77 to 78% for 10 minutes. This result demonstrates the use of optimized particle size, stringent manufacturing, and QA/QC processes, all used to deliver consistent performance. And last, we offer a family of dry and liquid breakers. They're trademarked as our BRINADD products. This will be a topic in our last webinar. All of the aforementioned polyacrylamide suspensions can be treated with our breakers to mitigate damage, especially at low temperature. We utilize earth metal or inorganic peroxides to deliver up to 20% available oxygen. As shown by the simulation on the right, an Ultra DR2 M4 suspension was compared to ammonium peroxide breakers and our BRAKE-C at 1.5 ppt. This is the red line. This was all at 125 degrees Fahrenheit. Compared to the baseline, which is the purple, no treatment, the viscosity was reduced to approximately 4 centipoise after 60 minutes of static aging. That concludes our presentation for today. This is a complete schedule of our webinars for this year, and we hope you will join us. At this time, I'm going to turn the production over to Kimberly, and any questions, comments you may have, we can entertain them now. Thank you.
Can you open that? All right. Perfect. If you have any questions, please post below in the chat comment. In this section, all you have to do is type and enter to post. Feel free, if you have any questions, you can also reach out to our sales and marketing team at TBC-BRINADD.com. Our phone number is there as well. It is our 24-hour number if you need anything. So right now, checking out some questions and comments. Thank you again for your time. Next week, we'll be reviewing our dry polyacrylamides, particle size, breakdown of efficiency, and how it can perform better for your well. So that will be next topic. We have an array of product lines. The next, following that will be drill-in, wall circulation, as well as our breakers and cross-linking additives. So. All right, everyone's shy today. If you have any questions or comments about the pricing of our product line, you can also reach our sales and marketing team at salesandmarketing@TBC-BRINADD.com for a personalized quote. If you do have a sales business manager that you're working with currently, reach out to them. They'll give you a personalized quote.